Our main goal for the rest of today is to solve polynomials. So first, in order to solve, they have to be factored, because then we set the factors equal to 0. So how do we first factor number 3? A times C would be 8. There is no GCF. What factors of positive 8 added to negative 9?
And 1.
Okay, now what's the only difference between this and a quadratic?
Nothing at all.
Yeah, it's not a quadratic. It's a fourth power, right? So it's a quartic. So we have to split it into squareds, x squared and x squared. Minus 8, minus 1. So it is a bottoms up, but we're breaking a fourth into squareds instead of a squared into x to the first power.
Oh.
Okay, but we're not done yet. We have to always divide by a, which is 2. So the first one simplifies to x squared minus 4. This one doesn't simplify, so where does the 2 go?
2x squared.
To the front, so 2x squared minus 1. Equals 0. That's the main difference between today and last class, is it's an equation now. It's equal to something. It's equal to 0. So we're trying to find out, when does this graph hit the x-axis, which is 0, right? The x-axis is 0. So we're trying to find the x-intercepts here. So we're still not quite done factoring. Which one of those breaks apart again?
X squared minus 4.
Yeah, this is a difference of 2 squares.
Minus 2x plus.
So one's plus, one's minus, x plus 2, x minus 2, and then why does this not break apart any further?
This is BMS 2.
Yeah, it's none of the scenarios in the left column. The 2 is not a perfect square.
Right.
So, and if we tried a times c with 0 in the middle, there are no factors of negative 2 that add up to 0. So we're just done with that one. It's a prime polynomial. Okay, now this is no different than quadratics. The way we solve is we set the prime factors equal to 0. So if we set this equal to 0, what do we get?
Negative 2.
That's one answer. If we set this equal to 0, we get positive 2. This is the newer part. If I set 2x squared minus 1 equal to 0, we actually have to do a little bit of work here. It's not just as obvious as these. So we need to go back to algebra 1 and add the 1 over.
Yeah.
Divide by 2.
Yeah.
And then square root.
Square root both sides. And how many answers does an even root have? 2. Plus or minus. Now, I'm not going to reduce radicals right now. You can just keep it as, technically the square root of 1 over 2 is the square root of 1 over the square root of 2. What's the square root of 1? 1 over the square root of 2.
No, sorry, my bad.
Now, if we really wanted to get into this, that's not a good answer, because that basement is made of gravel.
What?
Remember that?
So we discussed
Square roots in the denominator are not good. So what do I need to do to get rid of a square root in the denominator? Multiply it by itself on the top and the bottom,
I don't have root.
which gives us the square root of 2 over 2.
But do we have to do all that?
That is the best answer. But don't forget, we need to carry this all the way over to here. It's really 2 answers. Plus or minus the square root of 2 over 2. So how many x-intercepts did that polynomial have?
4.
4. The degree, what's the degree?
Yeah.
The largest exponent. So what is the degree of example number 3? It's a 4. That is how many x-intercepts you can have, up to 4. If it was an x to the 7th power, you could have 7 x-intercepts. Now we're going to find out that that's not always the case, but you could have that many, okay? So I want you to go to your calculator and graph the original problem. So go ahead and graph this thing on y equals.
working.
X to the fourth minus 9x squared plus 4 graph. Now you know what the x-intercepts are, so you should be able to kind of see your window. They're all within a 10 by 10, so your zoom should be fine.
So it's like that.
Yeah, how many times does it cross the x-axis? 4 times. Can you see the positive 2 and the negative 2 for sure?
Yeah.
Yeah, and then the other one's a decimal.
It's a W.
It's this. What were our other x-intercepts? The square root of 2 over 2, right? And the square root of 2 divided by 2 is about 0.7. So if you go back to the graph, see how it crosses a little bit to the left of 1. But do you understand why it's so important that you put plus or minus now?
Yeah.
Because that's actually, you're missing an x-intercept by not putting plus or minus. It has a positive and negative version of that answer on the x-axis. Okay? Try and do number 4 on your own. This is a difference of 2 perfect squares. So your first step should have been 3x squared plus 4, 3x squared minus 4. Don't forget it is an equation. It's equal to 0. Okay, the next thing you should do is you set each of them equal to 0. So if you get 3x squared plus 4 equal to 0, you'd subtract over the 4, divide by 3, and I'm taking the square root of a negative number. What is the square root of a negative number? I. So we get x equals, how many of you remember to put a plus or minus?
Me. I
Okay.
didn't get the right answer.
And the square, this is important, this is a good review from earlier in the year. Okay, the square root of negative 4/3 is the square root of negative 4 over the square root of 3. Now one of those is a perfect square, be it imaginary, but it is a perfect square. Yeah, the top one is 2i. 2i times 2i is negative 4. So this comes out to 2i over the square root of 3. Now, to rationalize, we multiply the denominator by itself, which gives us 2i squared of 3 over 3. Don't forget your plus or minus. That is what x equals.
I thought there was 2.
That was one of the factors.
Well, that is 2 right there. Plus or minus.
That is 2 answers, but that was only one of the factors, right? So now we need to go back to our other one. So we add the 4 over, divide by 3. It's basically going to be the real version of what we just did, right? Because it's not negative. So square root both sides. What is the square root of 4 over the square root of 3? Don't forget your plus or minus is 2 over the square root of 3. And then we need to rationalize the denominator. Comes out to plus or minus 2 square root of 3 over 3. That is the best possible answer. Next one. Ooh. Do number 5.
Number. I'm going to guess 36.
How many x-intercepts could we have? 8. But sometimes they come out to be imaginary. This lesson's a super good review of a whole bunch of things we've done this year. The goodest.
The best?
No, the goodest. Plus or minus. Because both of them.
Hey, Nolan.
Wow.
Show us your loudest scream.
2 real x-intercepts.
Oh.
I'm not sure.
When you said this,
I don't see.
Two is not, or 8 is not a perfect square. You can choose 2 as an 8. That's none of the scenarios.
You just grab trash from outside.
Yeah, some idiot just put, that person that walked by earlier just put trash on the ledge. Dummies.
What's that? I just yes, I know.
This is as far as the factors get. Those are both prime. 8 is not a perfect square.
I was gonna think.
So now we just set each of them equal to 0. X to the 4th plus 8 equals 0. You 4th root both sides.
How do you do that?
Yeah. That's.
How many answers does an even root have?
Yeah.
2. Plus or minus.
That's the 4th root of.
And
No, the I.
yeah, what we could do, so we haven't really gotten into simplifying radicals other than squares, but what you could do, so in your calculator, make sure your mode is on a plus bi. And then just type it in and see what you get. So the square, or the 4th root, 4 math 5. You know how to type that in. 4 math 5 is 4th root. 4th root of negative 8. It's ugly, but if you scroll over, you can see the I. See the I at the very end. It is imaginary because it's an even root of a negative number. So I really don't care about if you know how to understand that. But ultimately, did we get any good real x-intercepts out of that? No. So that means the other factor is the one that gave us some real x-intercepts. So that comes out to be the x to the 4th equals 8. 4th root both sides. And it is plus or minus because it's an even root. Plus or minus. And then for this, go ahead, let's just get a decimal. So the 4th root, 4 math 5 of 8, is about 1.68.
So you can put that?
Yeah, we haven't really done roots other than squares. We'll learn it actually when we get to our radicals unit, but for now, just understand that you'll have 2 real x-intercepts, and they'll be at about 1.68 and negative 1.68.
Could that have been factored as a difference of cubes?
Yes, you could have, actually. No, you couldn't.
You know what?
No. It would have to be, x to the 6th could be 2, 2, and 2. Or 9 would be 3, 3, and 3, but not x to the 8. Colon, what is my a? Because this is a difference of cubes.
Oh, that's an X.
Good? Jace, what is my b value? What times what is 125? 5. So we do a small factor, a big factor, minus, plus. Plus is the pattern we use.
Do we have to use the formula?
X minus 5.
Yeah.
X squared plus 5x plus b squared is 25 is your final answer there.
Yeah.
But it's an equation. It's equal to 0. So this one is easy.
Yeah, it is.
X equals 5. Woo! We got an answer.
Can you do it this way? Did I get the right answer?
Now, the other one is the problem. That is a prime quadratic.
Yeah.
You guys, you need to listen to this. That doesn't factor. X squared plus 5x plus 25 doesn't factor. The only way to solve a quadratic that doesn't factor is the quadratic formula.
What is that?
Hey, I knew it was going to come up somewhere.
Negative b over this root of 4 b
No.
or ac.
See if you can do it. Go. So here is our answer from the quadratic formula. And then if we graph that, x cubed minus 125, you'll see that there is only one
Mine's not straight.
x-intercept.
Mine's not straight.
Mine's not straight.